Welcome to the Smart Classes. Today we'll talk about refraction through a glass slab. So here's a glass slab. So this is the glass slab. And the medium around the glass slab is air. So the outside medium is air and this is the glass slab. So this is the instant ray, that's light is initially traveling in air, then it goes into the glass. And we know when light goes from one medium into another medium, जब light एक medium से दूसरे medium में enter होती है, it changes its direction, and that change in the direction of light is called refraction of light. Light bends towards normal because it goes from rarer medium into the denser medium. Air is rarer medium and glass is denser medium. Now that the refractive index of the glass is mu2 is the refractive index of the glass, and mu1 is the refractive index of the air. So this is the light ray जो पहले air में travel कर रही है, then it goes into the glass and bends towards normal because it goes from rarer to denser. And this is the angle of incidence, angle instant ray makes with normal, and this is the angle of refraction, angle refracted ray makes with the normal. And ये जो refracted ray है, अब ये फिर से इसकी refraction होगी bottom surface पे. तो पहले इस light की refraction होगी top surface पे, अब इसकी रिफ्रैक्शन होगी बॉटम सरफेस में, एंड रिफ्रैक्शन बॉटम सरफेस इट्स नाउ गोइंग फ्रॉम denser into air, that's glass to air, so it will bend away from now, it will bend away from now, it will bend away from now, and we call this angle of emergence, and this is angle of incidence, this is angle of refraction. So I is angle of incidence, and R is angle of refraction, and E is angle of emergence. जिस एंगल पे लाइट रे इमर्ज हो रही है ग्लास स्लैब से, दैट इज एंगल ऑफ इमर्जेंस. सो एंगल ऑफ इमर्जेंस. Now let's write Snell's law when light goes from air to glass. So Snell's law, as light goes from air with refractive index mu1 into glass with refractive index mu2, and Snell's law is sine of angle of incidence divided by sine of angle of refraction, sine of angle of R, equal to mu2 divided by mu1, while mu2 is the refractive index of the medium जिसमें refractive ray है, and mu1 is the refractive index of the medium जिसमें incident ray of light है. And let's call this equation first. Let's leave it as equation first. So पहले light enter हुई from air to glass, that's refraction at the top surface, and now अब light की दोबारा रिफ्रैक्शन हो रही है बॉटम सरफेस पे, और इस टाइम जो लाइट मिली ग्लास से एयर में वापस जा रही है. सो दिस इज अगेन एयर with refractive index mu1. So Snell's law as light goes from glass with refractive index mu2 into air with refractive index mu1. So it is sine of, now this angle is R, तो ये एंगल भी R ही होगा, but alternate angles. So this angle is R, तो ये एंगल भी R ही होगा, because these are normal. ये जो normals हैं, they are parallel to each other. So this angle and this angle, they will be equal, and reason is alternate interior angles. So sine R divided by sine of E साइन ऑफ एंगल ऑफ इमर्जेंस इज द एंगल जिस एंगल पे ये रे ऑफ लाइट ग्लास स्लैब से लीव कर रही है, इमर्ज हो रही है. इट इज mu1 refractive index of the medium जिसमें refracted light है divided by the refractive index of the medium जिसमें incident light है. Remember that refraction at top surface. तो जब हम consider कर रहे हैं refraction at top surface, then this is the refracted ray. When we consider refraction at the bottom surface, this ray becomes an incident ray. So this is equation second. Now if we multiply equation first and second, we get, so multiplying first and second, we get sine I, sine of angle of incidence divided by sine of angle of refraction into sine of R, that is angle of incidence for bottom surface, divided by sine of E, angle of refraction for the bottom surface, equal to mu2 divided by mu1 into mu1 divided by mu2. Now sine mu2 cancels, mu1 cancels, and sine of R and sine of R cancels, so we have sine I divided by sine E equal to 1, that is sine of angle of incidence divided by the sine of angle of emergence is equal to 1, or we can write sine I equal to sine E. Sine of angle of incidence equal to sine of angle of emergence, so ये कब possible है when I equal to E, that's when I equal to E, then sine of E equal to sine of I, या अगर sine I sine E के बराबर है तो इसका मतलब है angle I angle E बराबर है, angle of incidence equal to angle of emergence. Now if angle of incidence is equal to the angle of emergence, that means that incident ray and emergent ray, this is incident ray, this is incident ray, and this is emergent ray. Emergent ray, they are parallel to each other. So this proves I equal to E, this proves incident ray, this proves incident ray and emergent ray are parallel to each other, Now let's talk about lateral shift. Lateral shift. Now what's lateral shift? Lateral shift, it is the perpendicular distance between the direction of the incident ray and direction of the emergent ray. If we reproduce incident ray, this is actually incident ray, and if we अगर हम incident ray को produce करेंगे, so this is the direction of the incident ray and this is the direction of the emergent ray, और इन दोनों के बीच जो perpendicular distance between the direction of the incident ray and emergent ray is called the lateral shift. This is lateral shift. ये जो dashed line है, this dashed line is drawn in the direction of the incident ray. I repeat, ये जो dashed line है, it is drawn in the direction of the incident ray, and this is emergent ray. दोनों directions के बीच जो perpendicular distance है, that's called a lateral shift. या ऐसे भी हम बोल सकते हैं कि this glass slab we are not present. अगर glass slab यहाँ पे नहीं होगी तो this is the path incident ray would take, or this is the path incident ray would follow. Incident ray ये path follow करेगी कि अगर glass slab नहीं होगी, but due to glass slab it undergoes refraction twice. पहले इस ray of light की refraction होगी ये top surface पे, फिर इसकी refraction होगी ये bottom surface पे, और and then this is the direction, जिस direction पे ये emerge होती है ग्लास स्लैब से। नाउ ये जो परपेंडिकुलर डिस्टेंस है बिटवीन द डायरेक्शन ऑफ द इंसिडेंट रे एंड द डायरेक्शन ऑफ द इमर्जेंट रे, दोनों के बीच ये जो परपेंडिकुलर डिस्टेंस है इसको लैटरल शिफ्ट बोलते हैं। एंड लेट्स नाउ कैलकुलेट दिस लैटरल शिफ्ट। सो लैटरल शिफ्ट कैलकुलेट करने के लिए वी ड्रॉ परपेंडिकुलर, हम परपेंडिकुलर ड्रॉ करेंगे इस पॉइंट से ऑन द डायरेक्शन ऑफ द इंसिडेंट रे। एक्चुअली लेट्स कॉल दिस एज OA is the incident ray, yeah, AO is the incident ray and OB is the refracted ray. OA incident ray, OB is the refracted ray, and BC is the emergent ray. I will repeat, OA incident ray, OB refracted ray, and BC is the emergent ray. And let us draw BL perpendicular on the direction of the incident ray. So draw, yeah, let us draw BL perpendicular on OA when producing. So हमें डायरेक्शन ऑफ इंसिडेंट रे को आगे प्रोड्यूस करना है। So BL is perpendicular on OA when producing. तो आप देख सकते हो मैंने इसको आगे प्रोड्यूस किया है, दैट्स द डायरेक्शन ऑफ इंसिडेंट रे ऑफ लाइट। एंड इफ दिस एंगल इज R, this angle is I, then this angle will be, तो ये जो एंगल होगा it will be I minus R. Reason, I vertically opposed angle, so this angle also will be I. मगर इसमें ये ऑलरेडी R है, so this angle will be I minus R. This is I, तो ये सारा एंगल I है, मगर इसमें ये जो एंगल है ये R के बराबर है। If this is R, सारा I है, तो this will be I minus R. Now let's calculate sine of I from this triangle. So from right triangle OLB, this is this right triangle, O, L and B, ये यहाँ पे 90 डिग्री है परपेंडिकुलर। And from this triangle OLB, sine I minus R, it will be perpendicular, that's BL divided by hypotenuse, which is OB, perpendicular divided by hypotenuse OB, or we get BL equal to OB into sine of I minus R. Let's read this equation first. BL is the perpendicular distance between the direction of the incident ray and the direction of the emergent ray. और इसी perpendicular distance BL को ना lateral shift बोलते हैं, इसी को हमें कैलकुलेट करना है। Now again, let us look at this right triangle, O, B, and let's name this point as M. This OM is the normal. OM is the normal at the point of incident, जहाँ पे ray of light टॉप सरफेस पे इंसिडेंट हो रही है, OB इस point of incidence पे normal, OM. Now look at this triangle. From right triangle OMB. So right triangle OMB we have cos of R will be base divided by hypotenuse. Sorry, base divided by, and base is OM, and base is OM divided by hypotenuse, which is OB. OMB. Cos of R, it is base is OM, and hypotenuse is OB. Or we can write OB equals to OM divided by cos R. This goes up and cos R goes down. And let's call this equation second. and substituting second in first. So let's putting second in first. So when we put second in first, we get BL equal to BL is, remember, it's the lateral shift BL, perpendicular distance between the direction of the incident ray and emergent ray. So BL is OB and OB is OM divided by cos R into sine of I minus R. Now BL BL is D and that is lateral shift. That's lateral shift. And OM is, let's call OM is T, that's the thickness of the glass slab. Or you can say it's the distance between the top surface and the bottom surface of the glass slab. टॉप सरफेस पे जो पहले लाइट की रिफ्रैक्शन हो रही है, बॉटम सरफेस पे लाइट की बाद में रिफ्रैक्शन हो रही है, और इनके बीच जो परपेंडिकुलर डिस्टेंस है दो सरफेस के बीच, दैट इज d, which is the thickness of the glass slab. So OM is equal to T, that is thickness of the glass slab. So this equation becomes BL, which is perpendicular distance between the direction of incident ray and emergent ray, that's D equal to OM, that is T divided by cos of R into sine I minus R. Yeah, D equal to T times sine I minus R divided by cos of R, and this is the required expression for lateral shift. So this is required expression for the lateral shift. So this is the lateral shift. This is the lateral shift, that is the perpendicular distance between the direction of the incident ray and the emergent ray. It is d sine of I minus R divided by cos R. Now let's discuss some application part.